Hello and welcome to Smart Civil Engineering. Our mission here is simple: to bridge the gap between academic theory and practical application. From foundational engineering principles to cutting-edge construction techniques with methods, tips, we provide clear, actionable knowledge for the modern builder. This channel is designed specifically for engineering students, site trainees, junior engineers, and homeowners who want to understand the science behind the structures they live and work in. We have an exciting series of videos lined up for you covering everything from bottom to top. So, stay tuned, subscribe, and join our community of lifelong learners. In this video, we'll be discussing foundations, the most important part of any structure. A strong foundation is the key to every safe, durable, and successful construction project. There are many types of foundations, and they are generally classified into two main categories. Those are shallow foundations and deep foundations. Under shallow foundations, we have rubble foundations, pad footings, strip foundations, and raft foundations. Under deep foundations, we have pile foundations, pier foundations. In today's video, we'll focus on two types of shallow foundations, which are rubble foundations and pad footings. We'll look at where they are used, their advantages, and the basic principles behind each one. A foundation is the lowest part of a building, and although it is hidden below the ground, it plays one of the most critical roles in the entire structure. The primary purpose of a foundation is to safely transfer the entire load, or simply the weight of the building, to the ground. It provides stability, prevents excessive settlement, and ensures the structure remains safe and durable throughout its lifespan. Selecting the right type of foundation is an important engineering decision. To do this, we need to consider several key factors. Those are load of the building, the soil conditions and bearing capacity, site constraints and limitations, construction cost and time, environmental factors such as groundwater level and seismic conditions. After evaluating all of these factors and carrying out the necessary engineering calculations, we can determine the most suitable, safe, and cost-effective foundation for the building. Now let's talk about rubble foundations, which are one of the oldest and simplest types of shallow foundations. A rubble foundation is commonly used for structures that carry relatively light loads. Because it is constructed using natural stones, it is often one of the most cost-effective foundation options, especially in areas where good quality stone is readily available. Rubble foundations are commonly used for single-story houses, boundary walls and compound walls, small retaining walls, rural and traditional buildings, agricultural structures such as storage sheds and barns, small commercial buildings with light to moderate loads. The main purpose of a rubble foundation is the same as any other foundation: to safely transfer the load of the structure to the ground without causing excessive settlement. For this type of foundation, we use natural stones of different sizes. These stones are carefully arranged and packed together to create a strong and stable base. The spaces between the stones are then filled and bonded using cement mortar or another suitable bonding material to form a solid foundation. However, a rubble foundation is only suitable when the soil has adequate bearing capacity. If the ground is made up of soft clay, loose soil, filled land, or any other weak soil with low bearing capacity, a rubble foundation alone may not be sufficient. In such cases, the ground must first be improved. This is usually done by excavating the weak soil to a suitable depth and replacing it with well-compacted material, such as quarry dust, quarry sand, gravel, or other approved fill materials, depending on the engineer's recommendation. The dimensions of a rubble foundation depend on two main factors: the load from the building and the bearing capacity of the soil. There is no single standard size that fits every project. However, for a typical single-story house, the foundation is often constructed about 2 to 3 feet below ground level, extends approximately 1 foot above ground level, and has a width of around 1.5 feet. These dimensions should always be verified through proper engineering design and may vary depending on the site conditions and structural requirements. One important aspect during construction is ensuring that the stones are tightly packed with minimal voids. Larger stones are generally placed at the bottom, while smaller stones are used to fill the gaps. Proper compaction and good quality mortar are essential to achieve a strong and durable foundation. Now let's look at some of the advantages of rubble foundations. First, they are very economical when natural stone is available locally, which helps reduce material costs. Second, they are strong and durable, with an excellent service life when constructed properly. They also provide good resistance to moisture and weathering, making them suitable for a wide range of environmental conditions. Another advantage is that they require relatively simple construction techniques and do not need complex equipment, making them ideal for small construction projects. Finally, rubble foundations require very little maintenance and can last for many decades if they are built correctly. In summary, rubble foundations are a reliable and economical choice for light-load structures built on good quality soil. However, selecting the right foundation always depends on proper soil investigation, structural loading, and sound engineering judgment. Now let's move on to the second type of shallow foundation, the pad footing, also known as an isolated footing. Unlike a rubble foundation, which is mainly used to support load-bearing walls, a pad footing is designed to support individual reinforced concrete or steel columns. Each column transfers the load from its portion of the building directly to its own footing, and the footing safely transfers that load to the ground. Pad footings are one of the most widely used foundation types in modern construction because they are strong, economical, and relatively easy to construct. They are commonly used for single-story buildings with relatively heavy column loads, multi-story buildings, typically 2 to 5 stories depending on the structural design and soil conditions, steel-framed buildings and industrial sheds, water tanks supported by columns, pump houses, generator platforms, small commercial and public buildings. The main purpose of a pad footing is to safely transfer the load from an individual column to the soil while maintaining the stability of the structure. It also helps resist bending moments acting on the column and prevents excessive settlement of the building. Pad footings are generally selected when the building is supported by individual columns. The soil has adequate bearing capacity, structural loads are light to moderate, the columns are spaced far enough apart so that the footings do not overlap, and the groundwater conditions allow economical excavation. Now let's see how a pad footing is constructed. First, the footing is excavated to the required depth according to the drawings. The bottom of the excavation is then leveled and compacted. In many projects, a layer of lean concrete, also known as blinding concrete, is placed to provide a clean and level surface for reinforcement. Next, the formwork is installed according to the required dimensions. After that, the reinforcement steel is placed. Steel bars are arranged in both directions to form a reinforcement mesh. Cement concrete cover blocks are placed beneath the reinforcement to maintain the required concrete cover, which is generally between 40 and 75 millimeters, depending on the design and exposure conditions. This cover protects the reinforcement from moisture, corrosion, and fire. Depending on the structural design, the footing may contain a single layer or 2 layers of reinforcement. The size, spacing, and number of reinforcing bars are determined by the structural engineer based on design calculations. Once the reinforcement is completed, the column reinforcement is fixed in its exact position and securely tied to the footing reinforcement. After all inspections are completed, concrete is poured, compacted using a vibrator, leveled, and properly cured to achieve the required strength. Now let's understand how the size of a pad footing is determined. Every column supports a specific portion of the building. The vertical load carried by that column is called the axial load. In addition to the vertical load, the column may also experience a bending moment, which is the turning force that causes the column to bend. This can occur due to wind, earthquakes, or eccentric loading. A pad footing must be designed to safely resist both the axial load and the bending moment, while ensuring that the pressure on the soil remains within its allowable bearing capacity. In simple terms, a higher column load or weaker soil requires a larger footing. The required footing area is primarily determined by dividing the column's axial load by the allowable soil-bearing capacity. The thickness of the footing is then designed to resist bending and punching shear forces around the column. Now let's look at some of the advantages of pad footings. They are economical for buildings supported by columns. They are simple to design and construct. They require less excavation than many other foundation types. They generally use less concrete and reinforcement than raft foundations. Construction is faster, and reinforcement can be easily inspected before concrete is poured. However, pad footings also have some limitations. They are not suitable where the soil has low bearing capacity. They are generally not economical for high-rise buildings carrying very heavy loads. They cannot be used when columns are so close together that the individual footings would overlap. They are also unsuitable where excessive or uneven settlement is expected unless special ground improvement measures are carried out. To summarize, pad footings are one of the most common and economical foundation types for buildings supported by individual columns. When the soil has adequate bearing capacity and the structural loads are within a suitable range, they provide a safe, durable, and cost-effective foundation solution. Remember, choosing the correct foundation is never based on assumptions. It always depends on proper soil investigation, accurate structural analysis, and sound engineering design. Thank you for watching. Please subscribe and stay with us for more videos.